evening, ladies and gentlemen. Today I will talk about hydrogen obtaining by photocatalyst water splitting. This is the case when the water, which has high voltage needed for splitting, 1.23 volts are needed, are split into hydrogen. Water is one of the most common of hydrogens. Therefore, however, high energy required for splitting. The commonness gives better potential and, as potential energy carrier. Therefore, there are many attempts to split, make decisive by splitting this water molecule. Of course, the splitting of carbon energy is higher than ammonia or other compounds with hydrogen, but not so common. And some scientists for green energy requiring, they say that it should be by water, and Professor Francisco Medina from Rovira Universitat in Tarragona of Spain propose make a review of design such examples, focusing on photoelectrochemical hydrogen generation. A review and work is published in International Journal of Hydrogen Energy and is entitled A Review on the Design of Nanostructure-Based Materials for Photoelectrochemical Hydrogen Generation from Waste Water. Bibliometric analysis, mechanisms, perspective, and challenges. The work published in as International Journal of Hydrogen Energy, first reason, which I said, and photocatalysts were different size, nanoporous materials and fluoroporous for metals, mostly on metals, not on semiconductive polymers, which are more efficient in catching solar light than used, and the Professor Medina compares nickel, indium, silicon, lead, iron, and titanium and zeolites to show differences. The work is then showing nanowire and different type of nanoparticles of nanowires comparison. It's saying that there is power, biomass, and wind and solar, but still nothing is more powerful than sun. So why not to use this energy requiring for splitting and produce the requiring amount? The only material is the catching enough energy and enough absorbing and stability, because in different part of Earth, different radius is catching. First, showing as scheme on there are two attempts that can be on anode and cathode, photoanodes. But usually on anodes, given by solar wipe, and this solar light by semiconductive transfer to band gap enough to uh, bringing energy, and therefore is lower for semiconductive from 0.7 to 2.8 is optimal voltage conditions for high broad spectrum of light, because other branches give the light of UV screen not visible light, only infrared. But we want to mostly catch the light which is most suitable, so this is mostly by less than infrared, which is coming to air, so a little by this light. The the is the valence electrode. The sun is catching this, showing the enough band gap and energy. The voltage is coming and splitting. There are two atoms, nanosheets and charge transferring. In case of cyan and cadmium, cadmium is going to do energy in water, which is between the electrodes to split, hydrogen generation, and on one side we have hydrogen and other oxygen. So this is charge transfer. The other case is nanoparticles, nanoporosity, if porous material is better or non-porous better. Then it shows how in time from between 2014 and 2022 is where is the matter is development. Firstly, we have quantum dots and and hematite as very useful. Then is mixture of azodiazole poly conductive with dope with titanium oxide, so using tooth pads. However, we need to see that both method, titanium and cadmium, are not would be method which can be, but requires method of if for recovery of metals of waste, not by fossil for air, by depletion or mining, it will be great. So in other way, we need to recover method to make this uh, more sustainable. Then, and in 2015 also works about bismuth vanadium oxide with titanium, and they get around problem with shape and efficiently prevents bulk carrier combination, water oxidation kinetics, is supported by a layer of nickel borate composite for oxygen development analysis. At pH 9 causes cathodic change with water onset perspective. Then we have sensor being by nanoporous, which shows visible light cathodic photocurrent. But we also use to in high performance sensitive, but is very sensitively and selectively. So fast in case of nitrate in case of indium phosphide, the nanopores exhibit good performance also, quite uh, quality of one dimensional, so very small, but still indium is very rare and therefore very expensive one. There are also black silicon, which silicon is good, fine, but the case of silicon is safe until it's not powder, because in powder form, silicon in if too big concentration of air can produce a silicolysis, which is non-safe to uh, health. So the problem of nano silicon particles is that this silicon become on the size produce that can be dangerous, and into big size society, big uh, amounts can be some trouble. Because nowadays silicon seems to be fine because they not accumulate so softly like plastic, but we see only the powder form. So seems silicon to be more safer than polymer, but still requirement in case of after using these electrodes, the in silicons electrode doesn't recover so easily like others. So it's only using one, and then we have difficulties of recovery or recycling. Therefore, there is the titanium in 2017. They appear to platinum 9 nickel oxide composite. Then it's allowed to concurrent optimization. And this makes that use nanoporous nickel oxide shoe. This increase photocurrents in every nanoparticles, and more area is given by electrode, so more power generated. In this research, they investigated the trends and use in systems. Water nanocrystals, thin films. These are most common use in Web of Science. So most use in photocatalytic is how to efficiently stress water, and these electrodes should be easily recyclable. So what would be after use, and however how to produce electrodes quite quite adamant, stable, durable, and after use, not making this waste, because metal would be should be recovered and cannot be removed so easily. They need to be slotted in the special case for which we recycle or reusing. The question is energy requirements quite a lot. If the energy required will be sufficient or not. The analysis is link. The articles were growing or focus on this part followed was going until 2019. Get big area. Then due to not finding stability and coronavirus, they decreased rapidly into to 2023 just 1,000. And but increasing fraction of China in case of US, while Europe is retreating from this science. Therefore, this shows that the different cells, how this increase and conduction on cathodes and anodes. So wastewater On anode hydrogen is oxide, and of cathode is this hydrogen produced. P-type of dipper. The nanoparticles, which are from 1 to 100 nanometers, are used due thermal stability, resistance, hardness, and some powers are more better for purification of wastewater to get clean water for the electrolysis. However, the sun can be used in cleaning wastewater. The indium is very good material, but it's very expensive due to the other photo oxides. And this needs to be very carefully regeneration. So stability is high, but catalytic conversion and toxic is also the trouble in case of indium. So we need to use. And ionic form is another remark is achieved. In chloride media, especially polluting easily. So we need to avoid in case of indium chloride, also not very well in case of sea water, salty water. Better on this case is nickel oxide. But nickel oxide is heavy metal, so this can be even nanoparticles to very catch and how to prevent to block the small part to decrease if gold. Gold is also very fine. An open structure, it has high surface volume ratio, and pore ligaments in pore are especially well. But this is also the trouble that gold is nowadays mostly mined in unfriendly and illegal mining. Therefore, if we make this clean with illegal mining, the gold electrodes would very be expensive then. And therefore there is question how to make fast for gold electrode to make. Firstly, we need to be environmentally safely for production. The only matter is getting these anodes mostly from waste, electrical waste. This is the space that is a method that nowadays could be leading to avoid further devastation of the near mining of gold illegal mining, because 80% of gold is coming from illegal, and which makes cyanide and arsenic dangerous of fresh water nearby. The other is copper oxide, but still less efficient than gold and indium, but more safer, and some antimicrobial agent. So this can be also used to prevent in some for example, the case to prevent, for example, algae. So we have first algae, and gold, some algae are very dangerous to come to freshwater. So this copper oxide then, after the using and cleaning, can be used to avoid this. And this shows the lead. Lead is good, but still very difficult and quite heavy metal and not corrosive, but still very troublesome as with a waste. And this makes very unpopular. Silver nanoparticles are also fine, But the question is to there's 3,000 greater. Aluminium is the trouble are fine. The most frequent are now electronic silicon. But still, the silicon trouble is that in powder form becomes troublesome and can be, and or lowered up, it can be in big amounts if not deposited properly, become big danger and make psychoanalysis a pandemic if we not make design properly after using. So, so I don't think are also fine and cheaper than Indian and better, but still they are heavy metals, so we need to prevent metals to use. Bismuth vanadium and titanium and cadmium sulfide. Bismuth seems to be carcinogenic some parts. Therefore, in Germany, for example, titanium oxide is forbidden to use in food surface, food factory, and medicine. Therefore, we need to obtain to find metals which concentration is fine and not coming to food. So this is the all aspects that we need. So according to article, the focus on using photoelectrochemical due to not soft stability of light and weak irradiance is lower, especially after pandemic. So this is the all what I wanted to say. Thank you very much for listening.